Hello, and welcome back to EECS 367, Introduction to Autonomous Robotics, and Robotics 320, Robot Operating Systems. This will be our third lecture of the semester. The topic for today's lecture is going to be kind of an overview of the workflow that will be typical for the projects in this class. So we'll cover some background on JavaScript and HTML5, which will be the two predominant programming languages that we use for the projects in this course, as well as a little bit more background and kind of summary of Git, and then a few other topics as well. So before I get started, let me minimize myself even further so that I don't block the content for today's slides. All right, so to get started, so if you look at actually our first slide here, one of the things that you can notice is that this is actually HTML code that's being shown. And so if you take the code that's from this title page and you put it into a text editor, we can actually view ultimately this HTML code as a web page in your browser. So if you actually copy the code directly into a text editor, so this could be Sublime Text Editor, which is my personal favorite, but alternatively, any sort of text edit application, Vim even you could do through Terminal. You'll be able to paste the code into the file, and then if you save it as an HTML file, like for example, calling it this lecture.html, what you'll be able to do is you can actually open this web page in a browser. And so if you do that, what you should see is a page that looks just like this, where we've got our title for the page, and then we've embedded these two links back to the AutoRob homepage. And so while this is sort of a simple example, what we're going to be hinting at here is sort of what the typical workflow will look like for the projects in this course. And so we're going to be using HTML5 to interact with users and to display our simulated robots in an environment that's efficient and that your computer will be able to render very fluidly. And so within that, HTML is sort of the structural kind of scaffolding of the web page. So what we're seeing here in this current example is just pure HTML. So nothing will move. There will be no really user interaction apart from following those hyperlinks. And so that's where JavaScript comes in. So JavaScript then is a language that's used to make pages dynamic and to perform computation within the actual browser. So if we go back to our simple HTML file here, and we add in these script tags, and within the script tags, what we can do is we can sort of show this example that highlights some of the power of JavaScript. So the first thing that we can do is we can access the HTML document. So where we call document.body.innerHTML, that's where we're actually getting access to what's called the DOM, the document object model for this web page. And so this code now has access to the sort of web page, and we can actually modify it within this JavaScript here. So you can see, so what we're doing here is we're appending text, and in addition to the text, we're going to sort of base the result, the text that's displayed on the result of a computation. So at the end of this string, we have this 2 plus 2. So this kind of what'll happen here when we reload the page is we'll see the result of this JavaScript code executing in the browser. And so the power here that's highlighted is we can modify the actual HTML content, and we can base the modifications on computation that's done in the browser. And so this is really the while it's kind of a small example here, and we'll talk about more complicated examples as we go on in the lecture, but while this is sort of a small example, this really does hint at the power of HTML and paired with JavaScript. So once again, so if you make that change and you add those script tags, what you should see is shown here. So we have this addition at the bottom of the page where it's where our message that JavaScript added 2 plus 2 and got the result 4 is exactly what we sort of expected, and just is kind of a nice sort of little example to kind of motivate the rest of this lecture. And so really the goal for this lecture is to go over this background knowledge on JavaScript and also to introduce a sort of suggested or sort of typical workflow for the projects in this course. And so the workflow for the projects in this course really are not too dissimilar from that example that we just stepped through. So starting with project 1 that you may have already begun starting on. So what we're going to be working on in this project is implementing an A-star path planning algorithm in a simulated 2D world. And so this project will be implemented in this combination of JavaScript and HTML. You should only have to be editing the JavaScript component for this project, but the actual sort of results of your implementation will be viewable in an HTML file within a browser. And so the behavior of your algorithm will be viewable within sort of any modern web browser, right? Chrome, Edge, Firefox, Safari, and so forth. And your project will ultimately be submitted, once again, just as a reminder, through your Git repository. So if we look a little bit at what the typical workflow looks like on projects in AutoRob, so the way it works, right, is you're going to have a local copy of your source code. So if you go to your file explorer and you look for your local repository, right, so you'll find this set of files, right, this set of directories that contains all the HTML and JavaScript files that you'll be working on throughout the course. So the typical workflow is first you would sort of find the source code for the project that you're working on, and then with that source code there will be an HTML file associated with it. So for project 1, for example, if you go to your project path plan directory and then open the search canvas.html file in your web browser, you'll be able to see your resulting implementation of the project 1. And so if the code is working, you'll see behavior being shown, right? So you'll see the algorithm producing results, and those results will be displayed and updated in real time, and also based on user input within your browser. And so as you begin to then make changes to your code, the way that works is you'll have some sort of text editor. So there's no official text editor, but any that you're comfortable with coding in. So this could be Visual Studio, this could be Sublime Text, this could be TextEdit, this could be Vim, as is shown on this particular page. It doesn't. There's really no requirements for the text editor as long as you can edit the source code, and you're comfortable with it. So the typical workflow, first, so you would find the source code file that you want to work on. You would visualize the implementation within the browser, and then you would edit the source code within a text editor. And as you edit the source code, you'll make changes to it, you'll save the file, and then reload the browser. And as you reload the browser, all of your changes should instantly be shown as sort of updated behavior that you can visualize. And so the coding process, if we were to kind of lay this out in a flow chart, would look something like this, where at the top of the diagram, right? So you'd open the HTML file within your browser. You would then make some changes to the code within a text editor. You'd save those changes. You would then review or sort of like reload the file and view the resulting changes. And so once you've done this, as you're developing, the changes and you're implementing the features for the projects, you're going to want to save intermediate progress, right? So partially for the purposes of grading, but also partially to sort of store your project sort of remotely so that you don't lose track, or if something happens to your local copy, you still have a version saved. And so we'll be using version control to maintain that. And so the way this would work is once you feel like you've kind of reached some sort of checkpoint that you want to save the results, what you can do is you can commit the changes that you've made to your remote repository and push those changes. And so this will be, at a high level, this will be the typical workflow for the projects that we're going to be working on this semester. And so to go a little bit more into that, so in particular on this last part about pushing the changes that you make to your remote repository, we went over Git in sort of more detail in our first lab section. But just to kind of reiterate or to summarize that a little bit, your Git repository is going to store the history of changes that you make to your code. And so this is a really useful tool for you. It's what's called version control, so that you can ensure that that as you make changes or as you implement new features, or if you remove sort of old features or old attempts at implementations, all of those changes are tracked so that you don't forget what progress you've made, or you can sort of go back into the history of your project and find find any of the kind of intermediate results that you'll need. So on top of this, the other reason why Git is important, in addition to version control for yourself as a developer, the other reason why is because we'll be using a CI grader to grade the project implementations. And so the way that the CI grader will work is it will pull from the master branch of your repository. It'll run tests on the CI grader, and then it'll push the grading to your repository. And so the CI grader is a somewhat new feature for this course, and so any feedback that you have as we start to use it will be greatly appreciated. But in addition to the CI grader, all the grades will be reviewed by the course staff to ensure that they're accurate. And in addition, if you are looking for sort of feedback on your implementations, the course staff, we're happy to also provide that. So during office hours, when you come to office hours, we'll be able to see your implementation in the source code, and we can help with debugging or other questions about coding style and design and things of that nature. All right, so with this high-level kind of workflow that we talked about, let's maybe talk a little bit more about how this course is going to be using JavaScript and HTML, because of course the possible ways that you can use JavaScript and HTML are quite like if you look at the World Wide Web, for example, right? They're used all over the web. So how are we going to be using these two tools? So our course projects are going to be implemented for visualization within web browsers. And so this visualization is going to be based on JavaScript running underneath HTML. So the KinEval code stencil that we're going to be using for these projects was created specifically for this course, and specifically for this purpose of simulating robots in a user-friendly environment. And so all of the projects that we're going to be working on, they'll be viewable within the commonly used web browsers. So like I said earlier, so Chrome, Firefox, Microsoft Edge, Safari. The code should be compatible with all of these. So if you're having any issues, or if you're a little bit uncomfortable about running the code in your particular development environment, feel free to reach out. We are happy to help get you set up. All right, so to find the KinEval stencil, so once again, so if you go to the home page of our website, which is autorob.org, there's a link to the template that this stencil that we'll be using at the very top of the course kind of banner. So if you click on that link, it'll take you to our organization on GitHub, and also the public template repository. So this stencil then is what your project repos are based on. So if you ever want to refer back to the kind of default repository, like if you've made some changes and you can't recall exactly what you changed as compared to the original, this will stay up all semester, and so you'll be able to view the original here. And so with that, why, in addition to the ability to view the results in a browser, you might be asking, why really are we using JavaScript, right? So if you're coming from a pure C++ background maybe, or a pure MATLAB background, JavaScript might be a little bit unfamiliar. And so we want to spend a little bit of time kind of motivating our use of JavaScript in this course. So if we look at the possible options that we could be using, right, there really is a spectrum, if we want to call it that, of programming languages, where there's a set of programming languages that exist, and they all have different features. So if we look sort of on one side of this spectrum, we would have C and C++. And so you might consider these to be the languages that have very well supported usability in terms of the different machines. They have very high performance in terms of the control that the programmer has on memory resources and compute resources, and they're also very robust. So there's because they've existed for so long, they have a very well supported development environment. So on the other hand, you might have languages like JavaScript, MATLAB, and other scripting languages where the focus of these languages, or the sort of prioritization, is less on performance and it's more on kind of rapid development. And so there's a trade-off that's made here where the programmer maybe has less access to control over some of the memory resources or some of the compute resources, but what you gain in JavaScript is sort of a much easier development framework that's in terms of speed of development, because you're not worrying as much about those low-level details of the compute resources. And on top of that, the scripting languages typically have higher support for visualization and user interaction capabilities. And so that's really the part that we're focusing on. Because this is a simulation-based course in robotics, right, we really care a lot about the ability to visualize. And on top of that, we want to cover a breadth of subjects within this scope of robot operating systems. And so the ability to kind of rapidly develop these projects is really desirable for us because it gives us the chance to explore, right, these topics from path planning to forward kinematics, some motion control, collision detection. And so the reason that we're able to do that is because the language of JavaScript supports this faster development cycle. We're not as worried about handling the pure kind of performance constraints that we would if we were going to embed these systems in, let's say, C++. So then you might also be familiar with some other languages, right? So there also is a set of languages that are sort of in between these two extremes, right? So for example, Python, right, Julia, these are some languages that make trade-offs between these two extremes of kind of having control over all the performance aspects versus more kind of like rapid development. And so these are options, but they also have pros and cons, right? So in terms of potentially readability of the code, the overhead cost of in terms of memory or in terms of compute resources. So in Python, for example, this would be like the how effective the garbage collector is at managing your memory resources. And so across this spectrum, all languages have pros and cons. So since we're going to be using JavaScript in this course, you might be asking, well, what are the pros and cons for JavaScript? And so like all languages, it does have its own set of kind of unique pros and cons. So if we look at those, the first thing is that, a very important thing is that, JavaScript is free to use, and in addition, it follows an open standard. And so one of the benefits of following an open standard is that it's adopted widely in addition to the fact that it's free. And so for the case of portability, so browsers, virtually every modern web browser has an implementation of a JavaScript engine within it that we can use and that you use every time you log on to any web page. In addition to this, JavaScript has really outstanding visualization tools that have been developed. So in particular, 3JS, which is one of the tools that we're going to be using this semester, is really a pretty incredible tool. So that it can do 3D rendering in modern web browsers at upwards of 60 frames per second, with really impressive performance. So if you're curious on web visualization, I'd recommend check out this 3js.org. The sort of example section. They have some really impressive projects there if you're curious. But we're going to be implementing some of our own in some of the later projects as well. In addition to this, JavaScript, it's relative. If you come from a programming background of like C and C++, learning JavaScript is really not too difficult. Syntactically, it's the same, and a lot of the worries over memory accesses and things like that kind of get abstracted away in JavaScript, and sort of are not the concern of the JavaScript programmer. And so building onto that, JavaScript is also weak typed as opposed to being a strong typed language. So once again, this makes developing in JavaScript very familiar for C++ programmers. Like, we have this saying here that JavaScript is C without discipline. I think that really, you will, if you come from a C or C++ background from EECS 280 or EECS 281, that I think is the feeling you'll get with JavaScript, is that it's going to feel much less strict and much less constraining. And so that, we view that as a pro, but you could also view that as a negative. So if we look at some of the negatives, so for one thing, JavaScript for security reasons has limited access to networking. And so that does limit what you can do with JavaScript within browsers. And in addition, for security, JavaScript is not the easiest language to use for file I/O, and especially within browsers. There's some other kind of quirks of JavaScript, right? So like floating point issues tend to crop up in JavaScript when they wouldn't crop up in some other languages like C++ or MATLAB. And in addition, right? So where the programmer benefits from that, from the kind of lack of discipline, there is a performance cost in JavaScript, which is that it tends to be less efficient in terms of compute and less efficient in terms of memory resources. And the other kind of con with JavaScript is that sometimes you can have some challenges debugging, especially if you're involving asynchronous programming into the mix. It can be challenging there. But overall, right, for the sake of simulating robots, the benefit of having outstanding visualization tools, and for the sake of sort of rapidly developing these projects so we can cover the breadth of topics in robotic operating systems that we want to cover, JavaScript, the appeals of JavaScript really are desirable for our purposes. And so to expand a little bit more on this phrase here, JavaScript is C without discipline, because we anticipate that many of you are coming from that background of EECS 280 and EECS 281, of really kind of a C-based, C++-based kind of programming background. And so if you are coming from that background, JavaScript is going to look very familiar. Certainly syntactically, JavaScript is syntactically is almost the same as C++, for example. If you're coming from more of a MATLAB or scientific language, or like scientific computing language, the syntax is going to look a little bit different, and the data structures are going to look a little bit different than what you're used to, but your basic programming concepts are still going to apply within JavaScript in terms of function definitions, variables, and so forth. So if you are new to programming, we do strongly recommend that you either have taken or will take in parallel one of these courses listed here that covers kind of programming concepts. And so for anyone, if you're feeling uncomfortable with some of the programming, or if you've started to work on project 1 and you're finding issues with the programming, feel free to reach out to the course staff. We're here to help you. So either at office hours or over Slack, just message us, and we will happily provide resources, and we can talk through any of the content that is challenging. So to go a little bit more into detail about where is JavaScript typically used with HTML. So these two technologies really build the foundation for all of modern web development, and so typically these so virtually every single web browser is running HTML and JavaScript. So how you're watching this lecture, for example, the YouTube page that you're on is built on HTML and JavaScript. So HTML stands for Hypertext Markup Language. So this is the sort of foundational language for expressing content on web pages. And in particular, it uses what's referred to as the document object model. So if you ever see the abbreviation DOM, D-O-M, this is referring to the document object model. And so this document object model really kind of provides the scaffolding, the kind of high-level structure for content on web pages. But within that, there's no dynamic content in HTML. So where the dynamic content comes in is with JavaScript. So JavaScript then runs within the browser and can modify the document object model to provide that sort of user interaction, or any kind of animations, or really any changes to the content of the HTML page. On top of that, there's You'll also see references when you look up if you're looking up documentation on these web technologies, you'll see CSS references. So CSS stands for Cascading Style Sheets. This is a language, a tool that's used to describe styling components of HTML elements. And so we're not going to be relying on that for this course. So you don't need to worry about CSS. But if you see references to it when you're looking for up documentation online, this is what it's referring to. So if we look more at this document object model, this is really the core kind of data structure, if you want to think about it that way, of web pages. And so an HTML document is what specifies this document object model. So within an HTML document, there's a tree data structure, which is expressed as a set of markup tags, and the document object model is then essentially what, after this HTML page has been parsed, it forms this DOM object that allows programmatic access to the elements of the underlying HTML page. And so there's two really important global objects that are worth remembering. So the first is the window object. So as shown in the figure here, so the window object is sort of this overall encapsulating root element of the DOM that corresponds to a particular browser tab. And within the window, the other important global object is the document object. And so this document object is what maintains the current state of the document. So this is what the browser is sort of currently rendering on the page. And so when you load the page, this document object is what gets populated with the elements of the HTML file. All right, so the best way of kind of going through this is if we step through an example. So we have an example on the course homepage. So if you go down to schedule and you look at the under the lecture for today, we have this hello.html example. So we'll use this to step through this document object model and go through kind of step by step what it looks like. So if you open this HTML file in your browser, you should see the page shown on the left. And what we're going to do now is we're going to step through the DOM and look element by element, just so that we can kind of understand this idea of the document object model as a scaffold or this structure of the content that's being displayed. So within the HTML file, if you view the source code, so if you open up a text editor and you look at the HTML file itself, you'll see the code that's shown here. And so what we're going to do now is we're just going to step through element by element and look at how it corresponds from the code to the document object model. So the first thing is any HTML page will start with an HTML tag, and so this specifies the root element of the DOM tree. So within this, then, all of the content that's shown on the page is within the body tag. So and for each one of these tags, there will be an open and a closing tag. So then highlighted towards the bottom, then you can see the closing tag for the HTML and the closing tag for the body. So within the body, like I said, is where all of the content that's displayed resides. So within this, the first thing we have shown on the page is this header text, right? So we've got Chad displayed within this kind of bold font header. So the H1 tag, which encloses the text, is what controls that content being placed on the page. Separately, then, you can put just raw text within the body, and it'll appear just as text without the bold and without the large size as we had in header. If you want to have some sort of spacing, you can start a new paragraph with a paragraph tag, as shown here. And then each one of these elements, as we're stepping through, then what's highlighted on the left is its position within the DOM. And so you can see, for example, that within the paragraph element that we created, a child of that element tag, which is highlighted in red, is the text. So in this case, it's the new paragraph text. And so this DOM tree is what allows a program to access these various components of the web page and potentially make changes to them or query what value is stored in parts of the page and so forth. So it's basically what the programs will do, what the JavaScript code, for example, will do, is it'll be able to traverse this tree and search for the data that it wants to operate on. All right, so if we keep stepping through, then the next thing we have here is a canvas tag. So the canvas is what can be used to draw. So we can draw shapes, we can draw lines, and so in project 1, for example, the path planning environment is displayed within a canvas element on the HTML page. And so so after the canvas, then the final element here that we have is this JavaScript. So anytime you specify a script tag within the HTML document, that is specifying that there's a section of JavaScript code. So so once the browser renders this tag, it'll execute the commands here within the JavaScript, or more precisely, a JavaScript engine within the browser will then execute line by line this JavaScript. And so if we step through what this JavaScript is going to do, so what it's doing is it queries the DOM tree for the canvas that we created. So you can see the first line there that var canvas equals document.getElementById of my canvas. That's finding within the DOM tree, within the document, the canvas that we created with the ID my canvas. From there, then, it's the following lines then actually populate this canvas with a series of shapes that are drawn. So the calls to fill rectangle, for example, is what's drawing the black rectangles forming the border of that kind of black square, and then filling in the single black square in the upper left corner of that border. And so this this example illustrates the DOM tree, and our stepping through each of the element tags is hopefully helpful in understanding how these HTML pages are structured with respect to this tree of elements. So in particular, as you start to work on the projects in this course, we aren't going to rely on modifying the HTML components, but it's useful to have this background knowledge, because if you look at the HTML files, you'll be able to understand essentially where the projects are being visualized within for example the canvas element of project 1, and this gives some context to how the HTML files connect to the JavaScript. All right, so within the JavaScript, then we have another kind of short, quick little tutorial example that you can use if you're not familiar with some of the syntax, for example, of JavaScript. So again, if you go back to our course homepage and you look under the schedule for today's lecture, you'll see another example HTML page here, which is JavaScript by example. So if you click on that page, you should be brought to a page that looks just like this. And so what you can do is if within your browser, you could alternatively look at the source code for this after saving the file as within your text editor. But alternatively, browser tools have this view source option. So if you go into the settings of your browser, you'll be able to find a view source, or if you right-click, you should be able to find view page source as one of the options. And so if you do that, you'll actually be able to see the raw source code within your browser for this particular page. And so for our purposes, if you scroll, so this, like I said, so this example is sort of a quick example and sort of tutorial of kind of basic JavaScript programming. Again, quick and very basic. But if you scroll down within the HTML page, you'll see this example of a set of HTML elements that we were talking about, right? So you can see our HTML tag at the top. We've got our body tag, and then within the head tag, which is information that's not displayed, but it's sort of meta information about the page. You can see we have this script tag within the head, and the script tag defines a source file, which is this JS overview.js JavaScript file. And so this is the code that actually is going to be executing on the page that you saw when you clicked on the HTML page in your browser. And so for our purposes, we're going to step through some of the code on this from this JavaScript file, and in particular this tutorial JavaScript coding function. So if you look at that jsoverview.js file, you'll find this function, and this is meant to be a sort of very succinct example of how you can program, how you can do programming in JavaScript. So it's going to cover object notation, functions, variables, and sort of the basic programming concepts that you'll need. So within this file, let's step through kind of the key concepts. So to start with, so how do we define variables within JavaScript? So JavaScript has a set of primitive data types. So I think in total there are 7. So there's number, string, boolean, there's undefined, and there's a few other primitives. And so these data types can be assigned to variables within JavaScript, right? And so variables are declared when, upon the first time that they've been assigned some data. And so by default, JavaScript variables will be globally scoped, and by globally scoped, it truly means globally scoped. So across functions and across files, global variables can be accessed within JavaScript. And so if you don't want to define a global variable, then what you can do is you can use the var. So in this particular example, string global is a global variable because it is assigned data, but there's no var in front of the variable name. Whereas the line below, where we have var boolean local, that is a local variable because the var has been defined before the variable has been declared. And so the other then important thing to note within this example is how to do comments. So for single line comments within JavaScript, you can use the double /. So this should be familiar to you if you're coming from a C++ background. And then the other thing, so to actually do the assignment for variables, we use the equal sign, right? So this is pretty typical of most programming languages, but in all of the examples here, right, we've got variable name equals to do the assignment, and then some data that we're wanting to assign to the variable. All right, so to make this a little bit clearer, maybe we could break down each one of these examples and look at precisely what each one is doing. Right, so in the first example, we have our string global being assigned this data that is a string, quote, this is a global variable. So the variable name in this case is string global. The variable value is that string of, quote, this is a global variable. And because we didn't use the var keyword in front of the variable name, that's the reason why this will be a global variable, right? And then contrast that in the second example, we use the var keyword to say var boolean local is assigned true. And so in this case, right, we have variable name being boolean local, and the variable value is true. And so hopefully this makes it even like a little bit clearer. All right, so moving forward to data structures within JavaScript. So in addition to the primitive types, which we talked about a couple slides ago, the objects within JavaScript are the core data structure and really the core data type that are used within the language. And so objects within JavaScript are an associative data structure. So it'll store a collection of keys, and each key will be associated with a value. So you can think about this like a mapping from key to value. So a key value pair data structure. So to define object within JavaScript, you use the curly brackets, right? So in this first line of the example here, you can see we assign my object with an empty object, right? And so following that, then there's a number of ways that you can actually insert key value pairs into these object variables. So you can use dot notation as shown on the second line, where we assign the string Michigan to the university property of my object. So we refer to the keys of objects as properties of the object, right? So in this case, university is a property of this object, and then the values of those keys are the mapping that results. So like I was saying, so dot notation is one way that you can insert and access data from an object. In addition, you can use bracket notation. So as shown on the third on the third code line of this example, where we assign the string EECS to the department property of my object. This is another way of assigning properties to objects. And once again, the double forward slashes on each of these, on each line here, is denoting a comment. So any text that follows a double slash for each line will be interpreted as a comment and not as code. And so, in addition, I'll mention, so the other thing about objects that's important is, so here we're showing assignment of properties, but if you want to access the data that's stored within a particular property, the same kind of rules hold. So you can use dot notation, you can use bracket notation, and that will work. And you can interchange them. So if you use dot notation to assign a property, you can then use bracket notation to access the property. So as you work through this JavaScript HTML example that we have, feel free to edit it to try out some of these alternatives and see, sort of make sure that they work, or check what breaks, so you can kind of build your intuition about the language and about the syntax. All right, so also with respect to objects in JavaScript, there's another way that you can define objects within the code, and this is another way also that you can define objects as separate files. But apart from that, so it's referred to as JavaScript object notation. So within your code, instead of defining an object dynamically, where as we did on the left-hand side, where we say this my object is equal to this empty curly brackets, and then we assign each property one by one, an alternative that works just as well is you can do what's shown on the right, where you actually initialize the object with each property specified in the syntax shown, where you have property name followed by colon, followed by the data that is assigned to that property. And so if you organize the properties as a comma-separated list within the curly brackets, this is another valid way of specifying an object within the JSON format. And so with that, the other kind of crucial detail to understanding data structures within JavaScript is that the variables themselves are, you can think of as references. So when this example that we had here runs within the code, what's going to really be happening sort of behind the scenes is there's going to be a data structure allocated within memory. And so this data structure within memory is what actually holds the properties of the object and the data that's assigned, like the value of the data assigned to each property. So for example, in the figure on the right, we're showing in this tabular format each property that was assigned to the object that we created. But our object itself, the variable that we create, so this myObject variable, is actually a reference to the underlying data structure in memory. So if you're coming from the C++ background, this idea of reference should be familiar. And so the question then that we should ask is, what happens if we assign this data structure that we created to a new variable? And so the answer is that since JavaScript bases its objects on references, that new variable copied object will additionally be a reference to the underlying data structure in memory, right? And so this is a really crucial point to make sure that you understand, because if you do this within your code and then you modify the copied object, right? So in this case here, like if we say copied object.course number equals 567, and we want to understand what's going to happen, well, what's going to happen is that the underlying data structure gets modified, and where the course number property is updated to be 567, despite the fact that both of these references point to this same underlying data structure, right? And so if you then view the myObject.course number, it's going to print out 567, because again, that myObject variable is a reference to this shared underlying memory and data structure. And so if you're not familiar with references, this can be a little tricky at first, but feel free to reach out at office hours or over Slack if this is confusing, or if you run into any issues with references. All right, so another useful data structure which is itself technically an object, but is arrays within JavaScript. So an array is an instance of an object data with numeric keys. And so, for example, so you can define an array in JavaScript as shown here. So if you use the brackets with comma separated data elements, this will form an array. So in this particular example, if we run this code, this is what would happen underneath the hood, so to speak. So we would have we'd have the myArray variable, and this would be a reference to an underlying data structure within memory that is this object with numeric keys, right? So on the right hand side figure, what we're showing on the left column are the numeric keys for this array, and on the right hand side and on the right hand column we're showing the actual data type values associated with each of the keys, right? So it's this order. So it appears as this ordered list in the code, but underneath the hood, it's worth kind of understanding that JavaScript is treating it as an object with these keys and value pairs. In addition, arrays have by default a dot length property that will maintain the current length of the array, and so you can access that as shown here with the myArray.length, and that will return a number corresponding to the number of elements in the array currently. And so in addition to this, based on this sort of use of references within JavaScript, one thing that you can do is you can actually point essentially objects to one another. So in this particular example here, where we set the phone number property of my object to my array, what that will look like graphically is the following, right? So we create this phone number property for my object, right? So for this data structure that's in memory, which is pointed to or is referred to by my object and copied object, we've created a row for phone number, right? So we've created this key value pair, and within the phone number property is a reference to the underlying data structure, which is referenced by the myArray variable. So graphically, this hopefully is clear, but like I said, these references within JavaScript can be tricky if they're new. So feel free to follow up if there's any questions on this, or if you're running into any bugs, as you're working on the projects that you think might be related to references. We can certainly go over this. Again. All right. Another important detail about JavaScript is that it is a dynamic typed language. And so what that means is that the type of a variable can be changed upon assignment. And so as a result of that, you might start with the variable being a number, and then if you assign it with string data, it'll be updated to be that string type. And so that is handled implicitly. So the programmer does not need to explicitly do a typecast. It'll be handled by the JavaScript engine without the programmer explicitly doing it. So for example, in this case, we could take our myObject.phone number property, which was pointing to the array, and we could then where the array contained this sequence of number types, we could actually modify one of the elements from this sequence to be a string type, and JavaScript will perform the following. It'll actually update that element of the underlying data structure with a string. And so again, this happens implicitly. The programmer didn't have to typecast that element of the array or dynamically cast it. It will automatically be converted underneath the hood. So that covers at a high level some of the key details about data types and data structures within JavaScript. So the next thing that we'll talk about are control statements. So JavaScript supports C-style if-else statements as well as for loops. So these are the two, I would say, probably most important control statements that we'll be using. And so we have an example of how to use these shown on the left, with including usage that aligns with the data structures that we've been talking about. And so the syntax here should look familiar if you come from a C background. But if it doesn't look familiar, if you're running into any issues, once again, feel free to reach out, and we will go over this in more detail during office hours. So within JavaScript, one of the key tools that we use really throughout the language is operators, right? And so these are tools essentially to manipulate data elements and compare data elements. So this slide highlights some of the built-in operators within JavaScript. And so we won't step through each one of these. They should look very familiar from comparable programming languages, but I do want to point out a couple of nuances. So one of them being the difference between strict equality and weak equality within JavaScript. So highlighted by the red arrow on this slide is the operator for strict equality. So 3 equal signs denotes the strict equality operator. And so what this will do is when it does a comparison between two variables, this strict equality will only evaluate to true if the type of the underlying variables are the same and the data itself is the same for each of the variables. In contrast, if you only use 2 equal signs, which would be sort of a weak equality, JavaScript may do some underlying casting for the variables before it checks if the data itself is the same. So the weak equality will not enforce that the type of the variables be equal before checking if the data itself is equal. So this is a nuanced point, but as you begin your implementations, you should consider which of these 2 equalities you want to use depending on the behavior that you're looking for. Another example of an important operator is the addition operator. So in particular, the addition operator is overloaded for strings so that it'll act as a concatenation operator. So this is useful to know, especially for debugging. So if you would like to concatenate strings for debugging output, this makes it much easier than having to have a function that explicitly concatenates the arrays, for example. All right, so as a brief tangent, one thing I want to mention is just a brief note about LaTeX. And so this is something that you may see us use within Slack, and it's really a tool within academia to express mathematics in a formal TypeScript. And so this is just a small note, right? So within Slack, if we're trying to express like the formal mathematical expression for, let's say, like the distance calculation or some other formal mathematical function, you might see us type it in the following notation, where we have, like, it's enclosed within the dollar bracket, or like the dollar symbols. The reason for that is that it's really meant to be rendered by LaTeX. And so we're just doing this as a way of denoting what portion of our message is like a formal mathematical object and what portion is just text, because sometimes over Slack it gets very difficult to express what's a variable versus what's just our description of the variable. So if you ever see us use these dollar signs within Slack message, we've written them so that it could actually be read, or it could actually be rendered into formal LaTeX as shown like in the bottom here. But for the purpose of reading it, it's worth remembering that when we use those dollar symbols with some mathematical expression, we're meaning to convey that that's an equation, essentially. And so this is really, the core staff generally will only do this when, we'll only express this when it's needed, but over Slack it can be sometimes hard to express mathematical formalism, and so this is what we'll use. If you're curious, so LaTeX is used widely within academia, so if you're curious, a skill set I actually think is worth you looking into. I'm certainly glad that I learned LaTeX when I was an undergrad. There's Overleaf has a good set of guides, and also there's a nice editor that's LaTeX It, that has like really nice support for doing this rendering in a fast fashion. But again, this is just if you're curious. There's no requirement that you use LaTeX or anything like that for this course. Okay, so now back away from the tangent. So another really important component of JavaScript and virtually all programming languages is how we can implement functions. So a function is actually an object within JavaScript. So most, other than the primitive data types, pretty much everything else is an object within JavaScript, functions included. And so a function is a block of code that executes in a set of statements in sequence, right? And so unlike C, JavaScript functions do not declare a return type, right? So JavaScript, again, is a weak typed language. So, for example, here we have this function sum of A and B that returns the A plus operator with B. So we don't have to specify that this function would return a number. We don't have to specify that this function would return a string. JavaScript will actually interpret that for us based on the input to the function. So shown in the lower half of this code example, right? So you can see that when we run the function with number input, the result of the function is a number, right? So 3 plus 67 results in 70. Whereas when we run the same function with strings, we get a string output, which was the concatenation of the substring 3 and the substring 67. So this is a nice property that makes it much faster to develop, but if you're coming from a strong type language, this might look unfamiliar. So just be aware of this. So with functions, we can within JavaScript, one example of how we can use them is with recursion, right? So recursion is an example of a function calling itself. And so in some of the later projects in the course, we will, recursion will be a tool that will be useful for your implementations. So to kind of convey an example of what recursion is, so we could consider the case of trying to calculate a factorial, right? So in this case, let's say 6 factorial, right? So 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. And so this calculation can be implemented in a function as shown in the lower half of this slide and also in the JS overview example that we have. So within this factorial function, essentially what we're doing is we're just trying to express one operation within the recursion, and then within that the function will call itself based on the base case, right? So the first line within the function checks whether or not we're in the base case being that the input number was 1. If the input number is greater than 1, we will recurse, so we'll return whatever our input was multiplied with the factorial of the input number minus 1, and that will express this factorial calculation. So within that, then, or sort of following that in this particular example, we're expressing this, or we're calling this function with input number 6, and so within that, the way JavaScript will actually represent recursion is by using a function stack, a function call stack. So when we call this function fac with input 6, the function stack will have a new local variable scope pushed onto it, as shown on the right-hand side of the slide. And within that, then, if we kind of step through this function, we're gonna create this local scope for the function call. We're gonna then step through and check the base case. So in this case, the input with number 6 is going to be larger than 1. So we're going to return input number 6 multiplied by another call to this factorial function with 6 minus 1. So in this case, because we have another function call being made, we add that function call to the stack. So we have a new local variable scope, and we go through the same process, right? So now with input number 5, we check the base case. Input number 5 is greater than 1. So we're going to return the input number multiplied with another call to the function with input 5 minus 1, which is 4. So once again, we're going to create a new local variable scope, push that to the stack, and continue this process until we reach the base case. So once we've reached the base case, right? So now the input to the function was 1. So we return 1 from the top of our call stack, and that then is going to get popped from the stack. So we then return 1, move back to the top of the stack into that local variable scope, and continue this process of returning the value that was returned, and then popping the local variable scope from the call stack. And so this process continues until we are left with no elements in the stack. Right, and so we get our correct result. So we covered a lot at a high level, we covered quite a bit of JavaScript and how to use JavaScript. So like I mentioned throughout, we are happy and looking forward to talking more about this during office hours and during the interactive sessions. And we understand that JavaScript might be unfamiliar, so we're here to help. And so any questions really about objects, data structures, operators, anything related to the projects, we are happy to talk about. So one tool I would recommend using as you start to work on your projects is the built-in browser console. So this is a really useful debugging tool that's built into modern web browsers. So what is it? So it's, like I said, so it's built into modern web browsers, and it's used to log information associated with a web page. So this could include errors, it could include warnings, logging messages, security errors, all sorts of things. But for our purposes, what it's really useful for is you can choose to print out messages from within your code, and on top of that, you can use the console to check the state of variables during the execution of your code. And so, in particular, while the web page is actually executing with JavaScript, the console has access to all the underlying functions and global variables that the JavaScript has access to. So how to access this? So it'll vary slightly depending on which web browser you're using, but in general, if you go to the settings of your web browser and you look for either the developer options or web developer options, you'll see a set of tools, and the one that we're talking about here is the web console. You can sometimes access it also by right-clicking on the page that you want to inspect, so if you can't find this within your web browser, just come and talk to the core staff. We'll be able to help find it. But once you open the web browser, what you should see is a window pop up on the screen that looks something like this, and within it, this console is accessed directly to the JavaScript engine that is executing the page that you're viewing. And so what that means is this JavaScript console can actually take in any JavaScript commands. So this is somewhat like a Python interpreter or a MATLAB interpreter, if you're familiar with those, where you can execute commands as shown here, and you'll see the results returned. And so in addition to this, you can modify the actual web page itself, right? So you can actually, in this case, update the document object model, similar to how we did at the start of this lecture, but you're doing it from within the console and not from the JavaScript that's embedded in the page itself. And so anytime you see error messages or when you print output from your JavaScript, this is where it will appear. It'll appear within the console. So it's a very useful tool for that reason. So in addition, another really useful developer tool that's built into modern web browsers is a debugger. So once again, if you go to your browser and you look under developer tools, you should see these options. So if you go to the web console and then if you select the debugger tab, what you'll find is access to the source code that's running underneath the web page, including the JavaScript files that are executing. And so one of the tools that's built into these modern browsers is that you can set breakpoints within the JavaScript, and you can use the debugger just like you would with any sort of debugging tool, like for example GDB. So you can set breakpoints, you can step into the code, over the code, and you can and then you can interact with the code, you can interact with the variables during once the code has reached a breakpoint. So for example, in this particular browser, the way that you can use this is you can open the debugger, and then if you select a specific line of code from within one of the source files, that will set a breakpoint within the code at that specific line. So once the code has executed and reached that point, the execution of the JavaScript will actually pause. And so at that point, once it's paused, there will be a set of buttons that it might look slightly different on your particular browser, your particular version of the browser, but these tools, like these buttons that are shown here, are what lets you step through the code. So you can step into functions, step out of functions, step over functions, and control the flow of execution that way. And the other thing I'll mention, like I said, like I kind of hinted at, is I think a really useful debugging strategy is if you set a breakpoint within the debugger, then you can go back to the console, and once the code has reached that breakpoint you set, it's frozen in time. It's like the code is essentially frozen in time. So within the console, then you can interact with all of the global variables. You can print them out. You could even edit them. I'm not sure if editing them is a good strategy for debugging, but you can print them out and see the state of all the variables at that specific breakpoint. So it's a really useful tool in these browsers. All right, so now that we've talked about JavaScript and how to develop with JavaScript, what the workflow is, how to debug, let's now try an actual animation example to try and convey the high-level idea of how animation works within web browsers. Because within simulation, of course, we are going to be using animation. So to help with this, we have another example on the web page. So if you go back to the schedule, back to today's lecture, we have this hello anim HTML page. So if you click on this link, you'll see in the browser a simple example of how animation can be implemented with JavaScript. So you should see this in your browser, right? We have this bouncing ball, and so let's step through and show how animation is actually implemented within the HTML framework that we talked about and using JavaScript. All right. So if you look at the source code for this page, you'll see the following source, right? So we have our HTML root element, and within the body, we have once again a canvas where we're drawing the actual animation. And so to actually do the animation, we have this JavaScript, right? And so the high level framework that is implemented here and that is also going to be implemented in our projects is this idea that we initialize our animation, or we initialize our simulation, right? Where within the initialization we have our setup of variables that are needed for the simulation, and then crucially we start the animation. So within the JavaScript tag here, you can see that we define this point variable, right, or this point object, and so this is the variables that are needed to actually control the animation. So it's the sort of parameters that are going to be used, and then following that, we initiate the animation by calling the animate function. And so if we look at the animate function, it does 3 key steps. So first, it uses this request animation frame. So this is a built-in function that will automatically request that this function gets recalled at the next, basically at the next time step. Following that, then for the current time step, we update the state of the animation, which you can think of like updating the state of the simulation, and then we draw the results of that updated state to the canvas. And so this idea of setting a callback for the next time step, updating the current state, and rendering the current state, that framework is really the core of how we animate and how we simulate these robotic systems in browsers. But also more broadly, within web development or within simulation frameworks for robotics, this is really the core framework that's used, right? You have callback functions where at each time step you update the state of the simulator and you render the current state of the simulator. And so like I said, so we're sort of focusing in on this animate function for the framework. And so if we kind of schematically draw out how this works over time, these are really the core steps. So we start out with some initial state, which with like some initial function, which initializes the animation. And so we can think of this as being like a callback from the previous time step, right? Or t minus dt to denote the previous time step. And so within the current time step, right, so like within the first animation call shown on this slide, we first request animation frame, which is setting up our callback for the next time step. We update the current state, we draw the current state, so that at the next time step, automatically the animate function will get recalled, right? So this simulator is going to get recalled again and continually update and draw the state. And so it's this sort of chain over time, right? Where at every time step you update the state, at every time step you draw the state, and then you continually do this. And so that's really the highlight. So if you can understand this idea of setting up a callback to the next time step, and then basically rendering the current simulation state, that's really the core of animation. And certainly it's the core of how we're going to be simulating our robots for the projects in this course. And so as you start to interact with code, you'll start to recognize this structure. And so hopefully this example in this simplified format can help illustrate the key concept of how we run animation. And so the other thing I'll mention on animations is we have a few other examples. So there's another little more elaborate example on the home page with animated text that moves throughout the page. So if you're interested and you're excited about animation, this is an interesting one that feel free to look at. But there's really no shortage of examples on how to do animations within web development. So if you are curious about this, there's a couple resources from Professor Jenkins that he's implemented. So here's one project, for example, and he's got another project here. And if you're looking for more, I've got there's a whole bunch that I can recommend. For one thing, like I said earlier, like on the 3JS site, they have some really cool examples. But if you want to go even further, feel free to reach out to me, and we can talk more about sort of web development and animation. All right, so with that, the kind of final topic for today's lecture is just sort of a brief overview of the stencil to help kind of orient you within the code base now that you have it locally and you're starting to work on project 1. So the first thing just want to emphasize again is for the content that we talked about in today's lecture, we actually have this in the repository under the tutorial.js folder. So you'll find our tutorial examples there. For starting on project 1, we have this initial recommended starting point, which is the tutorial heap sort folder. So within this, you'll find an HTML page that's shown on the right-hand side here, where it's an illustration of your heap data structure, which will be used within the path planning. But I'll just point out that nothing within tutorial heap sort will be graded. So the only graded portion of project 1 is what's in project path plan. So within project path plan is where you'll implement your heap data structure as well as your A-star planning algorithm. And this is the portion of your code base that will be graded for project 1. And so more forward-looking then, as we start to move forward within the semester, the next project that we'll be working on is a pendulum control problem. So we'll be simulating the physical dynamics of a pendulum arm, and then also implementing a controller to control the arm towards specified set points. So the code for this will be within the project pendulum folder within your repo. And following project 2 then, for projects 3 through 6, all of them will be developed out of the core home.html folder. And so we'll be using a few of the other directories throughout these projects, but the core environment that we'll be working in is this home.html file. So who owns the code base? Well, the answer to that is both of us, in addition to Professor Jenkins and a few other collaborators. So to understand that, if you look at your repository, the original code base was actually authored and developed by Professor Jenkins, and included within that we have this license file, which is called the Michigan Honor License. So importantly, we will only grade your projects after you've signed this license. And so to understand this license, we ask that you read through it. It is essentially it's inspired by 3 sources. So a 3-clause BSD open source license, as well as the Michigan Engineering Honor Code and the Creative Commons license. So I'll sort of step through the key components of it here just to highlight. So the first portion, the three initial points are really inspired by the BSD3 clause license. And so this is with regards, this essentially just asks that redistributions of the source code retain the above copyright notice, and list the following conditions. The next point is inspired by the Michigan Engineering Honor Code. So we ask that any use of this source code for academic purposes, such as this course, follows the honor pledge, which is stated below, and then the final portion then is based on the Creative Commons license, which is sort of getting at academic citations of this work as they're used. And so then in the second half is where we have the honor pledge. So this is from the Michigan Engineering Honor Code. And then at the bottom, we ask that after you've read and if you agree to this license, that you would sign your name by adding it, appending it to the bottom of this file. So after you've signed it, it would look something like this, and you could then push this license to your repository. Professor Jenkins is still working on this license, so he has this warning here. But if you're interested in discussing more details about the license, or if you have concerns about the license, feel free to come to office hours, and we can talk about that. And so with that, as a brief wrap up, I just want to highlight the upcoming events for the course. So first, for this week's lab section, we will do a walkthrough of the Assignment 1 stencil. So we will go through the code and make sure that everyone is aware of exactly where the features should be implemented, and also answer any questions about Assignment 1 that you may have. Following that, next week's lectures. So first, on Monday, there will be no course meeting for the MLK Day holiday. And Wednesday's lecture next week will be on dynamical simulation. So look forward to that. And then finally, just as a final reminder, so the Assignment 1 is due January 21st at midnight Eastern Time. So if you have any questions about Assignment 1, any of the topics from today's lecture, any other questions about the course, do reach out over either Slack or during office hours. We in the course staff are really eager to answer any questions you have. So thank you for attending, watching today's lecture, and I look forward to seeing you this week.